Okay, so let's talk about Java programs and computers, chapter 1. So we start off by some objectives. We talk about understanding, we talk about how Java is related to World Wide Web, and how the API, JDK, and IDE work essentially in Java, writing a simple program, going to outputting to console, creating a compiling and running a Java program, and develop some Java programs using Eclipse. So, what is a computer? Computer is essentially a machine that has few components. One's the CPU, once the CPU, which is the brain of the computer. Once the CPU, which is the brain of the computer. So this is essentially the brain of the computer. The memory is basically where things are kept when the brain actually needs to work. So there are two types of memory. There is one memory that goes away when you switch off the computer, which is called volatile, and the second one is called non-volatile. Okay, this is basically your hard drive. This is something which is called a RAM, random access memory. When you buy a computer, you generally refer to RAM and you generally refer to hard drives. Then there is storage, which is basically removable storage, which is like disk drives, CDs, and tapes. Then the computer needs to be communicated, so it communicates using network card, which essentially connects to the internet. Also, it connects to other machines if required. Also, then there is something called modem, which works over the telephone line. It's called modulator demodulator, which actually takes the computer signal and converts it to a signal that the telephone lines can understand, and then from there it communicates with different computers. Then we have the input devices, which are like the keyboard and the mouse, which allow you to put things onto your computer. There are output devices which take the processing that the computer has done and puts them on the screen. Screen could be a printer, could be something which is essentially a monitor, or could be a 3D printer. So there are multiple things like that. Now, the CPU essentially is the brain. It is measured in megahertz, okay, and gigahertz. So the processors, Pentium is a type of CPU which Intel created sometime. There is also AMD, which is called Athlon. So there are quite a few processors like that. Now currently there is i5, i i7, you know, i3, which are Intel processors, which actually have a lot of transistors. On an average, something like an i5 will have about 750 million transistors, which is quite a lot, considering that, and more the transistors, more heat it produces. So as the number of transistors increase, on the same type of chip, it will produce more heat. Now, when processors get upgraded, then what they do is they make sure that less heat is produced so that they can put more transistors on the chip. So that's your CPU. Then you have memory. Memory is two types of memory. We talked about volatile and non-volatile, uh, and it is where you store data and program instructions for CPU to execute. A memory unit has a number of bytes which hold 8 bits essentially. So 8 bits is 1 byte, okay, that holds essentially information that the computer can process. Uh, so current content, so that means if you have limited number of memory, so you assuming have some amount of memory, if that gets filled, it gets overwritten with new information. So old information goes away, new information comes in. Then and this is how data is stored. So you have it's stored as binary because computer only understands zeros and ones. So like each character has a value associated with it. So when you actually see, like A has a different value, this is different, and few things here are different. So A has a different value, V has a different value, and that's how computer knows that these values are for these characters. Another thing is that it's represented as 0101. That's what a computer understands, and that's what is saved in memories, in the memory. So it's bits basically in zeros and ones, and you don't need to be concerned about that because you are going to not be doing work in zeros and ones. Then We talk about storage devices. Storage devices are devices like hard drives, disk drives. Then you have floppy drives, CD drives. So there are two types of device. This is non-removable storage, and this is all removable storage because you can take and carry with you. So all the so this allows you to read CDRs. This allows you to read CDRWs. These are rewritable drives. Then you have tape drives, essentially, which all can be removed. But you need the drive in order to put the media in it. So this is the media, which goes into, it looks like this, which you actually see, which goes into a drive, which looks somewhat like this, which has a slot here. If you press, it comes out, like a tray comes out, which has this thing on it. So you put this guy on the tray, so it goes in and it can read. This is what you buy in the store. Okay. Output devices. So we have output devices which are monitors and printers, which allow outputting of whatever you do in the computer to the device which you will actually see on. It generally is text and graphics. The resolution basically is this size. Like assuming you have a monitor which is say 24 inches, this is basically 24 inches. That's the diagonal, that's how you measure the size of the monitor. This will be say 768 by 1024. Essentially this gives the resolution of the monitor, and better, higher these numbers, better the resolution of the monitor, because that means you can have more dots on the monitor and the picture will look much better. The dot pitch determines the quality of the display. So dot pitch basically is the distance between two pixels. Each of the smallest unit is called a pixel. Okay. All devices in a computer communicate with something which is called a bus. Okay, that basically transfers information from storage devices to go to CPU, then to go to communication devices, then to go to input devices, and then output whatever you need to do. So the information flows back and forth. So if the CPU wants to read information from an input device, the bus is where everything actually goes from. So we talked about screen resolution, number of pixels in horizontal and vertical dimensions. So this is basically your monitor. These are pixels here, these are pixels here. Basically tells you more pixels. So we talked about 768, 1024. That's an example. This is a 17-inch, your monitor, and essentially the resolution can be set manually. You can change this resolution, but higher the resolution, better your clearer, your sharper and clearer your image. Okay, dot pitch is amount the distances between two pixels. Okay, so you have pixels and you have distance between two pixels. It is measured in millimeters. So that's your pixel on the monitor. That's another pixel. The distance between these two is essentially the distance between these two is your pitch, your dot pitch. Then you have communication devices which are modems, which are connected to a DSL line. When you get internet, you see it, you get a DSL line, and then when you get internet, you can get it through cable. So internet comes from outside. Cable modem is here, that connects to your computer, something like this. That's your monitor, that's your keyboard, and that's your mouse. Okay, so that's your computer. So this is your cable modem that is connected to your cable coming in, which converts it the internet to the what computer can understand. Then you have 10 base T, which is the speed of your network. Essentially, that means 10 megabits. Essentially, that means if it's communicating to outside, it'll count outside at 10 megabits a second. That means 10 million bits per second. That's what it can do to transfer data from the computer to the outside world. Then you have programs. A program is basically a piece of software that are instructions for the computer to follow so it can get results. Without programs, the computer is nothing, it just is a machine. With programs, it helps to do certain tasks. Assuming you want to calculate prime numbers or you want to calculate adding of two numbers, that's a program that actually does the task of adding two numbers. Programming languages. So there are multiple types of programming languages. So what you have essentially is, first is called machine language, which is essentially 0 and 1, because the computer does not understand any instructions essentially. So it only understands off or on, and off or on is 0 or 1, and that's basically binary. Binary is by is 2, so that's why it's called binary. Moreover, the program is difficult to read and modify. So if you have to add two numbers, you have to put some instructions and add binary information there. Now, generally, then there is something called assembly language, which essentially is instructions which are converted to binary so that the computer can understand. It is done by a program which is called the assembler. So keep in mind, assembler takes assembly instructions, which are essentially something which the operating system creates, and it actually makes it into machine code. So if you have to do numbers, so you say add, this is the resistor, this is the resistor. Remember this thing that we saw early on with the binary value? So it takes one of these resistors, takes another one of these resistors, and adds them essentially. So higher level languages is what you are doing. So Java is a higher level language. So this is something that you can understand, where area is equal to 5 into 5 into pi. This is the value of pi. So this is the pi r square, where pi is this guy, r is one of this guy, the second r is this guy. So that's what it's basically a higher level language. This is area of a circle with radius of 5, and that you can understand. These things kind of these things are kind of hard to understand, but you don't have to worry about them when you're doing Java. So these are some examples of languages. C is one, C++, C Sharp, Java, and Python. They are languages which are called higher level languages because they are easy to understand, and that's what human actually understands. Interpreting compiling source code. Program is called source code or source program because computer cannot understand the source program. A source program must be converted to what a computer can understand. The tool that actually makes is called an interpreter or a compiler. Okay, that takes source code and converts it to what a computer can understand. So there you go. So this is your higher level language, this is your interpreter, and this creates the output. So read one statement from a source program and translates it, machine code or virtual machine code, and then executes it right away. It is possible that this may actually translate to multiple instructions, which is fine, and then output it. Okay, compiling source code. So you take it, compile it into machine code, and then execute it. Remember, we use Java C in the lab, and we use Java. So basically, this is how it actually lines up. So this is your Java source code, your Java file. You do Java C, converts it into machine code file, and then there you go. So C is basically compiler. Okay. Operating system. Basically, operating system is the program that controls computer activities. Now there are few example operating systems with Windows, Mac, Linux, and programs are essentially like programs would be Word, Excel, PowerPoint. Your Chrome browser is a program. Operating system is Windows, Linux, and hardware is your PC, which is basically i7, i9, or your laptop. Those are all hardwares. This is essentially your programs, this is essentially your operating system, and this is essentially your PC. Why Java? Java is a general purpose language and it's an internet programming language, can run everywhere, can run on servers, desktops, computers, small handheld devices, essentially all of these. Java can be used for web and beyond. Java can be used for developing applications, running on browsers, running on handheld devices, developing applications for web servers. That's why Java is important. Java history was started in 1995, and Hot Java was the first Java enabled browser. So you need a browser, correct? Like Chrome is a browser where Java actually runs. So Java runs on a browser. Characteristics of Java. Java is simple. Java is object oriented. You can create objects like, so you can create an animal as an object, and then the smaller objects would be cats, dogs, hens, like, or cats, dogs, mice are all animals which could be objects and each have properties. We'll talk about this later. It's distributed, that means it can work on multiple computers if you choose to. Interpreted, robust, that means it doesn't break very easily. Secure, that means you can't hack it. Architectural neutral actually means that you can actually run it on any kind of machine. Portable, performance, it is fast, it's portable, you can move code from one machine to another machine. Multi-threaded, that means you can have a processor and you can run multiple processes on each, like you want to run prime number, you want to run Fibonacci, you want to run adding, you want to run divide, so all these processes can be run, so it's multi-threaded. Dynamic, you can change. So Java is simple, it's much simpler than C++, is modeled on C++, but at least simplified and improved. Some people prefer to Java as C++ minus plus plus because there are fewer negatives aspect of Java than C++. Object oriented, object is oriented programming is of this thing, important modeling paradigm. So it's distributed, it can work on several computers together on a network. So Java is designed to make distributed computing easy. Java is interpreted, it runs something called Java virtual machine, essentially code, and it's called bytecode. So Java C will create what you want to run in the Java virtual machine, and Java command will run in JVM. Is robust, that means there are not too many problems will show up in execution time. Java has eliminated certain type of error-prone programming constructs. Also, Java has exception handling. That means if you have an error, then the exception, it will throw the error, but the exception handler will catch the error and the program will not die. So Java implements several security features which programs cannot harm your program when it's actually running. Is architectural neutral. You can run it once and you can run it on a lot of types of computers. You can run on Mac, same code. You can run on a PC. Is portable. Architecture is portable, that means it can run on any platform without being recompiled. Performance, Java's performance, because Java is architectural neutral, Java programming is portable and the performance is good. Multi-threaded is where other language, you can call multiple procedures on Java and they can run all together. Dynamic, it's designed to adapt to evolving environments. No need for creators to install major software updates. New features can be incorporated very quickly. Different versions of Java. So you have 1.02 in 1995 and you have 1.8 in 2014. Few additions, J2SE, J2EE, J2ME. The one that you have to be considered about is J2SE. That's the one that you're going to use. Two popular IDEs, NetBeans and Eclipse. The one that you've used is Eclipse and the one that you're going to use is Eclipse. So writing a simple Java program. So you write simple Java program. This is like lab 1 and prints essentially welcome to Java. So you have few parts in it. You have a class essentially which is called welcome. So your file name will look like welcome. Keep in mind this capital has to match your file names. If you change this, you'll have a problem executing essentially. Also, this is the main driving function. So it drives the first thing that will run is this function, and anything in this function, anything in these brackets will be the first thing that run. And then it actually says outprint to Java. You can use editing using DOS basically, like command prompt like the first lab, where you create a file called welcome.java. Welcome.java is this code and this is basically this file. So if you look, this name and this name are exactly the same. You see, even the capital and the capital is the same, just because it's very case sensitive. You can also use Word to write your code and save it as a .java file, basically. So this is your file name. This is your extension. This is the name of the file. So how do? You create your code. That's what you are creating your code. Then you run Java. This is your code, source code. As you see, that's your source code. You do Java C. That means you're compiling. So if you have an error, you go fix the source code. That converts it to bytecode, which is looks something like this. You don't need to worry about that. And then you use Java command to run on the bytecode, and then you see world.java after that. So these are the steps that's important. This is the lab 1 that you actually did. That said, how it actually works is you have a computer, this could be Mac or PC. Then there is something that's on there, which is the Java virtual machine. Remember, you installed the J2EE, you install the JDK, and then you install the JEE, Java Runtime JRE, which is a Java runtime environment. That's this guy, and this guy is on there. So what you do is, once you compile, you generate code, essentially bytecode, and then you do Java. Then when you do Java, this is where it runs actually, and that's your compiled code when you do Java C. And this is when you do Java. This is the part when it actually runs, and that runs on your computer. So it could be any computer inside here. It could be any computer inside here, you know, and once the computer is there, so the Java virtual machine will run on that computer, which has Java bytecode running on that Java virtual machine. So this is the main enter method that we talked about. It's important to keep the signature the same, so this name has to always be the same. This is the statement that is going to execute. This basically puts a line of on the screen, and it looks like this. This is what it actually puts on there. Okay, so few things that you need to. So there is a JDK, which basically makes your JVM, where we actually went to actually run Java C. That's the bin directory has Java C. Class path is important because it tells, if you set this class path, it will know where to find this file. Then you don't need to type all this to run your Java C. And Java C essentially will work the first time, which basically is going to be Java welcome to Java. And then once you run, you can run using Java welcome. No node.java. This is basically the name of the class that you actually compile. It's the .class file. So if you see this guy, that's basically what you run, but you only run this without the class file. So you don't need the class .class, because some people make this mistake. You can actually use TextPad to write source code. Few things though. You have a class name, you have a main method, you have statements, you have statement terminators, which are essentially this guy. Statement will be system out dot print ln. Main method would be public static void main, so on. Terminator is the semicolon. Reserved words are like public. Comments are with // or with /* essentially, and then you can which anything in there, if it's multi-line, will work that way. Blocks are essentially these guys. These are comments. So there you go. So if you look, that's your class name. If you look, this is your main public static void main, the main driving function. This is what you look is your statement that you would run. This is what you look is a terminator. That's your basically colon at the end. Essentially, this is what you look is your reserved words, which is public class, public static void main, are reserved words when you are in Eclipse. Those are the ones that change color. Essentially, those are reserved words. Then these are blocks. That means this piece of code is basically part of class. This piece of code is essentially part of the method the main method essentially. and that's the class block, that's the method block. So symbols, opening closing bracket denotes a block, this is denotes a method, this denotes an array, this denotes a comment, string, and end basically is the end of statement. So if you put if semicolon, that means this is ended, it won't go into anything that it needs to execute after. So there you go. So that's your block, that's the function, that basically tells you about the function. This is the function, you're passing the string in it so that it can actually show it on the screen. That's your termination of your this thing. That's the program essentially. That's your comment. So this basically is your comment. That's your quotes where your string goes in, text or string. Programming styles, so appropriate comments, naming convention, proper blocks and spacing, and block styles. So appropriate comments, what the class is doing or what the date and submission. Also there is something as naming convention. So you can actually do a capital small naming convention, that's a name. So welcome is W, or you want to say add program. So A can be capital, P can be capital. Indentation is basically where you indent into, so like you have an if statement, then you indent what is under so that you know that's the next level as part of a block. Similarly, that's your indentation. That's indentation, that's indentation. So the two styles, so you can have end of line or next line, both are okay for blocks. So there are three types of errors. Syntax error, where your code is not right. When you compile, when you do Java C, it'll tell you like a semicolon is missing, or a quote is missing, only one side of the quote is there, or a bracket is missing. Those are all syntax errors. Runtime errors are which basically cause programs to abort. That means like 7 divided by 0 is a runtime error, because 7 divided by 0 is infinity and the program will have an issue. Logic error is if you're trying to calculate, say, temperature and it doesn't calculate it properly. That means if your answer is 72 but you get 36, the formula is incorrect. So like f minus 32 do I think 5 by 8. So instead of doing that, you say 4 by 8. That means the value that you're going to get will be wrong. The value that you're going to will be wrong. So it will be wrong. So the answer will be wrong, essentially. So incorrect. It will produce incorrect results. Like if you are asking for, say, Jack's address and he returns Jill's address, that's a logic error. So syntax errors, essentially, if you see syntax, this is quote missing, that's a syntax error. Then this is a logic error, something divide runtime error. So you have something divided by 0, it is a runtime error. Logic error is you doing 9 by 5 into 35 instead of, so this formula is not correct. So that's a logic error. So you can do Java NetBeans or you can do Eclipse, essentially. This you don't need to. So this is basically showing you a display message using a graphic user interface, and you can run that using this guy if you choose to, or this guy if you choose to, and code looks something like this. There you go. That's end of chapter 1.